Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all in class of real analysis. I am Azmat Ali. In today's lecture, we are going to discuss a very important topic from your textbook Introduction to Real Analysis by Robert G. Bartle. Uh, that is the direct and inverse images of a set. Before going to discuss this topic properly, we start from a question. Let me ask a question. Suppose I have a function f of x is equal to x square where x is greater than or equal to 0. Suppose I want to find f of 2. So I ask, how can we find f of 2? Your answer will be simply by just plugging x is equal to 2 in given function, we can find f of 2, that is simply 4. Similarly, if I ask, I want to find f inverse 8, how can we find it? Your answer will simply, firstly we find f inverse and then find the value of f inverse at 8. We can find the value of f inverse 8. It means you are familiar how to find the value of the function its inverse at any real number. But if I ask this question, how can we find the value of function and its inverse over an interval or over a set? This is our discussion of today, and that is what we will discuss: direct and inverse images. Direct and inverse images. Suppose I have a set E is equal to the open interval 0, close interval, 0 to 2. My function is f of x is equal to x square. I just want to find f of E. How will we find this? F of E is x. Firstly, f of E, this is not a single value. This represents a set. This is the first concept. When we apply a function over a set, then its output will always a set. This will not a single unique value. So f of E is a set. What type of a set and how can we find this? F of E is simply can be found by just applying square on these values. So here the first initial value is 0. So what is f of 0? F of 0 is 0. F of 2 is equal to 4, and for all the remaining values lies in this interval, we can only apply x square. We can only apply square on that values. So all those values after applying square on this E will be lies in interval 0 to 4. This just represent the direct image of E under F. Similarly, if I want to find F inverse E, how can I find it? Firstly, we find inverse of x, this function. Then we apply that inverse over this interval. We can simply find the inverse image. So F inverse E just represent the inverse image of E under F inverse. So one of the important thing that you will remember throughout the lecture, direct and inverse images always represents a set. This does not represent uh, this do not represent a single or unique value. Further, direct images of any set under F always just represent codomain or range, values of range is represented by direct images. This is the simple concept of today's lecture. Direct images of mapping just represent the elements of range or codomain. Similarly, the inverse image, when we find inverse image, this just represent uh, elements of domain that we generally take in form of x. So the inverse images are actually values of x when values of y are given, and direct images are the values of y when x is given. Now let us read properly all of these things from here. Let f is my function from a to b, with domain of f is a subset of a and range of f is subset of b. Let E is a subset of A, then the direct image of E under F is denoted by the set f of E and is defined as f of E is the set of all output values of f, that is f of x, when x belongs to E. This is the set of all images. Output values are also called images. This set of all images of elements of E under F. It may be noted that f of E is always subset of B. यानी mean to say direct images, the set of direct images is always subset of range of B. Similarly, let there is another set H which is a subset of B, then the inverse image of H under F is denoted by F inverse H and is defined as F inverse H is the set of all values that are in the form of X, that are actually pre-images, that are values of A when f of x belong to H. So f inverse H is the set of all pre-images or a set of all images of elements of H under f inverse. It may be noted that f inverse H is subset of A. This all discussion can be explained from this diagram. Suppose this is my set A, that is the domain, and this is set my B, that is the range. E is a subset of A, so here is set E. Similarly, H is subset of B, so this set represent the represent set H that is actually subset of B. Now let us apply direct image. Now we want to find direct image. So if we apply the mapping F over the elements of E. Suppose the elements of E are in the form of EI are the elements of F. When we apply the mapping F, then F maps these elements EI to set H. So these are always of the form of Y. So F of E, these are the elements under the mapping F that is denoted by Y are the elements of H. Similarly, when we apply the inverse image F inverse H, it will apply on the elements of H. Now suppose the elements of H are Hj inverse, Hj. When we apply F inverse on these elements Hj, these will lies in E. that are in the form of x. So from this figure we can clearly see that f of e is subset of b, and f inverse h is subset of a. Now I am going to discuss very important points of today lecture that you should remember. uh, Direct and inverse images of a set under a mapping are sets, not a single value. In very simple words, direct images are the values of y for given x. This is very important point. In very simple words, direct images are the values of y for given x, while the inverse images are the values of x for given y. In general, f inverse f of e, when we apply the inverse mapping over f of e, it will not equal to in generally E. Similarly, when we apply f over f inverse h, it is also not equal to h. This is true only in case f is bijective mapping. When your function f is bijective 1 1 on 2, then this result will hold. Now let us discuss some important examples and exercise question. This is the example 1.1.8 given in your textbook. A part. Let f is a function from R to R given by f of x is equal to x square. Then find the direct image of the set E. This is the same example that we have discussed above. This is my set E. We need to find the direct image. Direct image is the only set of all those elements which can be obtained by taking square of these elements. The direct image of E is simply a set which can be obtained by just taking square of E. Thus, the direct image of E is denoted by f of E, and direct images are always represented by the elements y elements. So this is close interval 0 to 4. Now let us say this set is equal to G, f of E is equal to G. Now my next target to find what is the inverse image of G. Okay, what do you say when we find its inverse? Is its inverse will equal to E back? So let us see here. The inverse image of G is denoted by f inverse G. That is the f inverse close interval 0 to 4. So f inverse G is this set f inverse 0 4. It means this just represent when this just represent or can be elaborated as when your y lies between this interval, what will be your x? Your x for these values of y. When y lies between 0 to 4, then what will be your x? So my target is to find x here, and these values of x just represent the inverse images. So to find the inverse images, firstly we find what is the inverse of this function f of x. My function is f of x is equal to x square. Let y is equal to f of x. From this I can write x is equal to f inverse y. It means let us we write y is equal to x square. From this relation we can find x is equal to plus minus square root y. Say this is equation number 2. By combining 1 and 2, both are the values of x here. This is also values of x, this is also value of x. It means your f inverse y is plus minus square root y. Or in other words, from this relation, x is equal to plus minus square root y. As inverse image is the set of all values of x for which y is this. So when your y is 0, what is your x? Your x is simply 0. When your y is 4, what is your x? Your x is plus minus 2. It means your inverse image is the interval close interval minus 1 to plus 2. So inverse images are simply the values of x. This is very simple concept. Further, you can see here uh, f inverse f of e is not equal to e here. How? This is inverse image, that is f inverse g. F inverse g. What is g? G is the set f of e. So it means your f inverse f of e is equal to the close intervals, minus 2 to plus 2. What is your set e? Your set e is close interval 0 to 2. It means, this is not equal to e. On the other hand, if we apply f over the function f inverse g, that is f of minus 2 to plus 2, this is equal to 0 to 4. In this case, f of f inverse g is equal to g. But if h is minus 1 to plus 1 close interval, and again we apply f over the f inverse h, this is the close interval 0 to 1, that is not equal to h here. Why in this case this is equal to g and this is not equal to h? This all depend on your function. Your function is y is equal to x square. That is not a one function, but for a single value of x, for a single value of y, for a single value of y, there exist two values of x. So when your y is positive, when your x is negative or positive here, then your y is only a single value. So it maps negative and positive values to the same value. That's why in this case it is equal to g, but in this case it is not equal to set h. So it just depends on the nature of your function here. Now let us discuss the second part of this example. This is also very interesting. The second part says, uh, let f is a function from a to b and let g and h be the subset of b here. We need to show that when we apply f inverse over the set g intersection h, here again you can notice that f inverse g intersection h, this is not a numerical value, this is not a real value, this is a set. So f inverse g intersection h is a subset of f inverse g intersection f inverse h. You know what is the criteria to show? Suppose I have two sets A and B, and I need to show that A is a subset of B. From set theory, you know, to show that A is a subset of B, we take an arbitrary element X from A, and later we show that X is also an element of B. This shows that A is a subset of B here. So the similar concept we will use in this example also. To prove the result, we take an arbitrary element x belong to f inverse g intersection h and show that x is also element of the right side. Let x is an element of f inverse g intersection h. By taking f on both sides, or simply you can say by taking f inverse to the left side, we have f of x is equal to f of x belong to g intersection h. As f of x is an element of g intersection h, so by definition of intersection, f of x is an element of g and f of x is an element of h here. If we consider the first part, f of x belong to g, this can be written as x is equal to f inverse g by taking f inverse on both sides, or by we simply say that we can by taking f to the right side, it become f inverse g. So this become x belong to f inverse g. Say this is equation number 1. Similarly, when we take second part, f of x is equal to h, from here x belong to f inverse h. As x is an element of x is a common element of these two sets, from 1 and 2 we have x belong to their intersection, but x was arbitrary element of this side. This shows that this is a subset of this. Now I move towards Question number 10 of exercise 1.1. Uh, I have a function f of x is equal to 1 over x square where x is non-zero and x belong to R. The first part says determine the direct image of f of e where e is a set of all real number lies between the 1 and 2 close interval. As I said above, direct image of f of e is the set of all images of elements of e under f, or simply these are the output of f given below. Uh, it can be defined simply by taking f over these values. For example, my function is f of x is equal to 1 by x square. When your starting value of x is 1, it gives us 1. Similarly, if you put here f of x is equal to 2 here, your answer is 1 by 4. As 1 by 4 is a smaller than 1, so we start from this number. So the direct image is the set of all values of y that lies between this 1 by 4 to 1. So direct image is the closed interval 1 by 4 to 1. Next, our target is to determine the inverse image f inverse g, where g is this set 1 to 4 closed interval. Inverse image of f inverse g is the set of all images of elements of g under f inverse. So we need to find f inverse g, that is f inverse 1 by 4, or we can simply say that we need to find the values of x when your y lies between this. The inverse images is the set of all values of x when your y lies between these two. So for this, firstly we find the inverse of the function. My function is f of x is equal to 1 by x square. Let y is equal to f of x. From this, x is equal to f inverse y. Write y is equal to 1 by x square. From this, we have x is equal to 1 plus minus 1 by under y. This is my inverse function. That is f inverse y is equal to plus minus y. This implies f inverse g is equal to f inverse 1 by close interval 1 to 4, and this will give us this. How? Inverse images is the value of x for which y is this. My x is equal to plus minus under root y. When we put here the first value of y, that is 1 here, we have x is equal to plus minus 1. We have two values of x. Similarly, if we put the last value of the interval from here, that is y is equal to 4, we have x is equal to plus minus 1 by 2 here. So your values of x lies in two disjoint intervals, minus 1 to 1 by 2 and 1 by 2 to 1. When you put y is equal to 1, you have x is equal to minus 1 and plus 1. Similarly, if you put the last value of y, that is 4 here, you again find two values of y. This is y is equal to minus 1 by 2 and this is y is equal to 1 by 2. We cannot find any other value in this portion here for this interval. So your inverse image is the simply are the values of x that lies in this interval. We can see this all from this graph here. This is the graph of f inverse y here. That have the two branches plus minus 1 by square root y. This blue branch is the graph of f inverse y is equal to 1 by square root y, and this red represent graph of minus 1 by square root y. How can we make this graph? This is simply like as suppose I want to make the graph of y is equal to f of x. How can we make this? We, for a given value of x, suppose x is equal to a, we find y, that is f of a. and we have order pair A is equal to A comma f of A, and then we plot all these order pairs on the graph paper. We can find the graph of y is equal to f of x. Now to make the graph of this function f inverse y, that is in term of y here, simply we take the reverse process. These are the values of y that we have given. Our y is 1 to 4. For each y we will find an x. We find x as like as when your y is here, y is 1, your x below is -1, and similarly for this y we have again x is equal to -1. So for a single value of y there are the two values of x, -1 comma 1 and 1 comma 1. This is my x-axis, this is origin, this is my y, actually this is y-axis, and the values of y are represented here. So for these y I can find the values of x here. Firstly, -1 to +1, -1 to 1 by 2, like this here, 1 by 2. So this area represent the first part of inverse image, and this area, that is from 1 by 2 to +1, represent the second part of inverse image when your y lies between 1 to 4. Again I repeat, how can we make this graph? If you want to draw the graph, simply by taking y and find the x from this relation. For a single value of y you will find two values of x, and by plotting all order pairs on this on the graph paper you can find the graph of x is equal to 1 by square root y, or graph of f inverse y. Here the graph of f inverse y, which represents the inverse image of the function f of x, the shaded gray region corresponding to the inverse image of this interval, which is the set of all values of x for which the function belongs to this interval, this x. So I hope now you have a clear understanding about direct and inverse images. Direct images are the simply values of the range or codomain, and it always in the form of y. Inverse images are only values of x when y is given. You have to focus only these two lines. Direct images are the values of y when x is given, and the inverse images are the values of x when y is given. So inshallah in the next lecture we will discuss the remaining question related to direct and inverse images of set given in your exercise. So let us see in the next lecture. Take care. Allah Hafiz.